Welcome to 5-3A, dividing polynomials. We're going to use long division in this video. You can see it says simplify. We have a polynomial here and divided by a binomial, and that what gives us the reason why we're using long division. Before I begin, I want to check the degree order and see if any of the degrees are missing. So you'll be thinking something like this. I got t cubed, t squared, t to the first, and none. 3, 2, 1, and none. I don't see any of the degrees missing or the variables missing, and we'll have a problem with that a little bit later. Now, once we got that, you can remember that the algorithm for long division from elementary school is that we put the divisor in the front, the dividend inside the box, and our answer, the quotient, will go on top. I like to begin asking myself, how would I get this leading term to 0 using subtraction? Because that's what we use in long division. So the exact same number, both of them are positive. If I subtracted it, would cancel out and give me 0. But we're not done yet, because we remember that we're going to put a number, in this case a monomial, up here, that when we multiply it will give me 6t cubed. So ask yourself, 3 times what gives me 6? And the answer is 2. And you want to put it into the next term column, which is t2. Now, what would I multiply t to the first power to get to t cubed? Well, the answer is right here. It's t squared. And if you follow this pattern, you will never forget what variable and what exponent to use. We're not done yet. Once again, we're going to have to take this binomial and multiply it by this monomial. And that's what I'm going to do right now. 3 times 2 is 6. T to the first times t to the second gives me t to the third. And then I have to multiply that by 1. So I'll get the exact same number, a positive 2t squared. You can see I have all the terms lined up according to the degree. Now this is simple. 6 take away 6, t third, that actually cancels out, and that's what my objective was. I'm going to bring this subtraction sign over, and I'm going to do the same thing I did here. I'm going to go 5, take away 2, gives me 3. I'm not multiplying, I'm subtracting, so I keep the base, or the variable t squared, the same. I'm going to bring down this negative 2t, and I'm going to start the algorithm all over again. I'm still subtracting. And to get this to 0, I would have a number that is exactly the same, 3t squared. Think to yourself, what would I multiply this 3 by to get to 3? That would be a positive 1. I have a t to the first, I need a t to the second. Well, all you got to do is look where this column is, and it's t to the first. There you go. Let's go ahead and multiply this out to check. 3 times 1 is 3. T times t, add the exponents, is t squared. Then I'm going to go ahead and multiply that one more time by this positive 1, and I get plus 1t. All right, I'm going to subtract again. You can see that this cancels out. That's what I wanted. And that's the pattern I'm using here. I'm going to go ahead and bring this subtraction sign over here. A negative 2 minus 1 gives me a negative 3. Bring down the t. I have another number, plus 1. I'll bring it down. Now I'm still subtracting. I want to have a number that when I subtract will get this to 0. And you can see the pattern was we had the exact same number, so this is a negative 3t. Now, I'm going to ask myself, what would I multiply 3, a positive 3 by to get to a negative 3? That would be a negative 1. Do I need a variable? Let's see here. Well, this is t to the first, and that's t to the first, and you look here, there's no t. Let's go ahead and check that. Negative 1 times 3 is negative 3. T times negative 1, well, that just carries over. Don't forget that we're going to have to multiply one more time with this positive 1. That gives me a negative 1. All right. This negative, if you remember, 2 negatives right here, changes that to a positive, and that's why that cancels out. I'll bring this negative over here. These 2 negatives change to a positive, and I get a positive 2. you can see that there's no more numbers to bring down. So I have a monomial, and this binomial cannot go into a monomial. We call this the remainder. Now, it's a little bit different from long division. In elementary school, we are going to take this 2, bring it up to the quotient of the answer, and we're going to create a fraction. This is where the remainder goes. Now, our fraction needs a denominator, and that's the same denominator or the divisor that we had here, 3t plus 1. Now, you can think of this as how am I going to connect this this polynomial to this fraction? Well, this is a positive 2, so that's what's going to connect it. Our next long division problem, you can see here, is almost the same. It's slightly different. We're still going to simplify. You can see here that I have a polynomial. This time it's being multiplied by a binomial, but we're going to focus in on this -1. I want you to think that in 5-1, or what we learned previously, a negative exponent's not allowed. If it's outside a parenthesis, what we do is we reciprocate, and when we bring this from the numerator to the denominator, we put a 1 there. And you can start thinking that, well, you know what? This means I'm going to put this under here. We have a numerator and a denominator, and that's what makes it a division problem, is this -1. We had to place it under here. Next up, we got to worry about our degree order. And let's see here. We have x to the 4th. We have x to the 3rd. But we don't have is a square, x squared. We have an x to the 1st, and we have none. All right. This is going to cause us a problem here. We're going to have to take care of this missing degree here. So I'm going to go ahead and take my polynomial, put it inside the box, put the divisor outside, and I'm going to make sure my x to the 4th is here, minus 3x cubed. Now, how am I going to take care of this missing degree? I want to make sure it's in 4, 3, 2, 1, none order. So what I'm going to do is I'm going to place an x squared and put a 0 in front of it. And that's the 0 property rule. Any number, no matter what it is, times 0 is 0. So this is just a placeholder, so we can still have all our degrees. All right. What am I going to do again? I want to get rid of this x to the 4th. I'm subtracting, so I want the exact same number. All right, you can see here that there's a 1 here and a 1 here. So I want a 1, and I have an x to the 1st, but I have an x to the 4th. Well, what would I do? Well, if you follow the pattern and put the number in the correct column, the next degree, I'm going to multiply by x to the 3rd. Well, let's see if this works. X to the 1st times x to the 3rd, add the exponents, I get x to the 4th. Don't forget, I got to multiply by the second part of my binomial here. 2 times 1 is positive 2 times x to the 3rd. All right, I'm ready to subtract. These cancel each other out. I'm going to bring the subtraction over here, so it's a -3 minus 2, which is going to give me a -5. I'm going to carry the x cubed. Now I'm going to bring down that 0, and you can see I made it a positive because it's easier to work with positives. I'm still subtracting. That's what the algorithm says to do. Now, in order to get this to 0 by using subtraction, I need the exact same number. So I need a -5 and an x cubed. Now I'm going to use this information here. How do I get this 1 to a -5? Well, I multiply by a -5. How do I get this x to the 1st to x to the 3rd? I'm going to multiply it, and it tells me right here, x squared. Let's see if that works. 1 times -5 is -5. X times x squared, add the exponents, gives me x to the 3rd. But hold on here. I got to multiply this by 2. Positive and a negative gives me a -10. 2 times x squared is x squared. All right, you can see here that this negative is going to change this to the positive, which cancels it out. I'll bring the negative over here. You see I have 2 negatives, so it's a +10 now. So 0 plus 10 is 10. I get x squared. I'm not done yet. I still have a number to carry down. So positive 5x. I'm still subtracting. I got to get this to 0, this degree here to 0. While I'm subtracting, it's got to be a 10x squared. All right, now I'm going to find my answer to put here in the quotient. What would I multiply this 1 by to get to 10? Well, that would be a positive 10. I have an x to the first. What would I multiply to get to x squared? Well, it tells me right here. X. Let's see if that works. 1 times 10 is 10. X times x, add the exponents, x squared. Don't forget the 2. 2 times 10 is a positive 20. And I carry the x here. I'm subtracting. This cancels out. I'll bring this subtraction over here. 5 take away 20 is negative 15x. And I'm going to go ahead and bring down this last one, negative 6. Still subtracting. I want to cancel this out, and so that means I'm going to have the exact same number, which is negative 15. What would I multiply by 1 to get to negative 15? That would be negative 15. I have an x to the first, and I have an x to the first. And do I need an x? No, this tells me right here. There's no variable here, so I keep it negative 15. Let's see if that works. 1 times negative 15 is negative 15. X times 15, well, carry the x. Now here we go. We get this. 2 times negative 15 gives me a negative 30. Negative and a negative changes to positive. That's why that cancels out, because they're opposite of each other. I'm going to bring the negative over here. The 2 negatives change to a positive. So now I have a negative 6 plus 30 gives me a positive 24. That gives me a remainder. Okay, it's a remainder. So I'm going to go to the quotient. I'm going to put the remainder on top of a fraction. My divisor here is going to be my denominator. Now, how do I connect this polynomial to this fraction? Well, I look for the sign. It's a positive. I put a positive here.